As mentioned, my name is Joe Eberly. I'm the Vice President of Growth and Sales Strategy at 4M Analytics. We are the folks who you saw on the video during the lunch hour. Our goal, very quickly, is to map the utility subsurface world at scale across the United States. We're on our path to doing that. In fact, I'd just like to mention we recently hit a milestone, finished the mapping process for the great state of California, which put us over 5 billion linear feet of utility mapping at this point. So that includes about 35 million records that we've gathered, synthesized, digitized, and put into our database. So that's a little bit about us. So as we get started here, I'd like to talk about a couple of things. First, give you guys some insights through some data points into damage prevention in the utility industry. So I'm going to call out 4 basic metrics. Every year, about $5 billion is spent on damage prevention measures. So the efforts to prevent damage in the industry by our utility owners. In 2021, there were approximately 220,000 utility strikes recorded in the US. Each year, at least $1.5 billion is spent on just the hard cost, the repair hard cost of those 220,000 utility strikes. Estimates, of course, are much higher than that when you count damages, capital loss, claims, those types of things. The numbers rise significantly to an estimated $30 billion a year. So if you're an MBA and you do the math on those types of numbers, what that indicates is the return on investment of that $5 billion is negative 70% as it stands today. These are not good numbers. So the question is, if we were to spend 10% more on damage prevention measures, should we expect a 10% reduction in the amount of damage? The answer is clearly no. Which means it's time for the utility industry, in our view, to do something different. The old way of doing things is simply not working. So, as an infrastructure, investments have multiplied utility damage prevention spending, the number of annual utility strikes, the utility repair costs, and the overall project budgets, schedules, and scopes have all increased. Like a highway traffic jam, the subsurface ecosystem is becoming more crowded and the engineering challenges more complex. Because of this, the approach to damage prevention in the utility industry needs to change. And this is why implementing a digital transformation paradigm is critical to ensuring the utility industry stakeholders are meeting the demands of utility management, utility coordination, and utility risk mitigation. That said, the challenges associated with the transformations are multifaceted and, as you guys know, very complex, often overwhelming. Today we're going to talk a little bit about these challenges, and as we begin, let's start with a quick round of introductions. Why don't we start with you, Steve?
Thanks, Joe. Good afternoon. My name is Steve Friedman. I work for HGR, which is a consulting firm, architecture and engineering. We've been around for over 100 years. I oversee our drinking water practice here in Southern California, and we have multiple business lines, architecture, transportation, water, and resources. I was very happy to see throughout the day that a lot of our clients have been here. A lot of the projects we've been working on have been mentioned today too, like the Union Station rehabilitation project, Pier B at Port of Long Beach, and if you were here, the very first session, a project I'm going to talk about a little bit today, Pure Water, Southern California, and I think we'll pass it on from here.
Aaron.
Hey everyone, my name is Aaron Goldstein. I work for Universal Engineering Sciences. We just rebranded to UES, so you may not be familiar with us. We are also a AEC firm, specifically focusing on testing, so CMT, construction material testing, geotech. But we also have some other major solutions, and one of those things is subsurface information modeling. And what we do is we use geophysics, other AI techniques like 4M provides for us. And what we do is we map out underground utilities and transform that data into something usable to meet current demands in this ever-changing ecosystem.
Thank you, Aaron. And Matt.
Good afternoon, everybody. My name's Matt Grimm. I'm with Granite Construction Company. A project executive there. I've been working with Granite for 19 years in the heavy civil industry, and Granite performs heavy civil construction across the United States of all sorts: highways, bridges, dams, rail, water infrastructure, and the sorts.
Okay, thank you, Matt. Steve, why don't we start with you? What are the biggest risks on most design construction projects that HDR works on?
Yeah, so most of us realize that every project is unique, but we'll usually go through a risk register as we're starting out, and there's some common themes that show up on all of them. It's usually schedule and budget, and we look for things that are going to impact those the most. What shows up number one these days has been supply chain. And that just didn't even show up on risk registers, I'd say, 2-3 years ago. But I expect within a few years, after we figure out these COVID impacts and the war in Ukraine comes to its conclusion, it'll probably drop off again. But what's most relevant for today is those subsurface unknowns. Where are those existing utilities? You almost always seem to hit one that you weren't expecting, and that causes both schedule impacts as well as budgetary ones. So really understanding where those are become a really big driver during the design phase. I can't speak as much to the construction side. I am a consultant after all. But that's where a product like yours, and I think there's others out there that are doing similar things, can come in real handy if you can really identify where those utilities are early on. It helps reduce the risks of extending schedules and budgets.
Thank you, Steve. Aaron, let's talk about standards for a second. From your perspective, what are the advantages of some of the newly updated 3822 standards that have been put in place?
Yeah, thanks. Is anybody in the audience familiar with the ASCE 3822 or the 3802 standard? I didn't figure. So basically, what it is a standard guideline of how to document existing utilities and also how to designate them. It basically starts off with a framework, if you will, going from quality level D to quality level A. Quality level D being the least accurate information, quality level A being the most accurate information. And what's interesting about this framework is we're basically compiling data not only from records reviews, information that we could be collecting from 4M's platform, but we're also doing an investigation in the field. We're validating true location of utilities. And we do that through using advanced geophysical techniques, non-destructive techniques, and some test pitting and test holing information. Now, what's great about doing this is not only are you able to document existing utilities out on site, but you're also able to determine any type of unknown objects. So that could be an underground storage tank, it could be buried debris out on site, which could impact the change order process. But the other great thing that's involved in this whole entire process is we're able to work to get the design from a general contractor on a design build project to meet what's actually out on site.
Thank you, Aaron. Matt, from your experience working with Granite, what are some of the major challenges your company faces, or you as a project leader, when it comes to overall project budgets, schedules, scopes, and specifically, how have you seen these challenges evolve over the last few years?
So much like Steve, I think the unidentified utility is one of the biggest challenges when you're out building a heavy civil project. When you hit an unidentified utility, it really changes the project from a proactive standpoint where you're in charge of your work, you're planning it, you're executing it, to reactive environment where you're going, oh, what do we do now? So with that utility, comes delays and schedule impacts and cost impacts and budgetary impacts. So pricing of the work is dependent upon the completeness of the contract and the identification of the unknowns, which with the increasing traffic jam of the utilities, underground utilities, it's becoming harder. Another area that I've been seeing evolution in this process is the CMGC delivery method, construction manager, general contractor, so where the contractor gets involved early in the process in the design phase, working with the designers. We're able to provide utility investigation early. We're able to provide alternate designs, alternate construction methods that might mitigate a conflict with a specific utility, which has been helping. And then obviously identifying those conflicts early in the design process with whether it's AI or utility investigation.
Got it. Thank you, Matt. Steve, back over to you. Considering all the complexities and the challenges that we know are out there, how do you and or HDR make conceptual alignment or siting decision in today's world?
Yeah, well, I'll tell you how we used to do them. It used to be very kind of gut feel. You can look at a street and the general area that you're in and determine whether there's going to be a lot of utilities within that alignment or not. You'll say, okay, what's the shortest way to get from point A to point B, and you pick an alignment. You say, well, let's avoid residential streets because then you're going to hit every service connection around. So we'll go with a more major street. But then is the city going to allow you to disturb such a heavily trafficked area or not? And this kind of gets to the project that we were just selected for Metropolitan Water District, Pure Water Southern California. We're putting an 84-inch diameter pipeline right down the center of Carson. And Metropolitan, in their foresight, had a bunch of conversations with them early on to get their buy-in to, yes, we can use that street. But putting an 84-inch pipeline down that street means you're probably going to hit utilities no matter what you do. So we didn't have a whole lot of choices on where we went. But a product like yours, I could see being very beneficial during that conceptual stage, because you get a good feel for where those utilities are, and you can try and make choices that avoid those more complicated areas.
Steve, thank you. Aaron, given that there is tools out there, advanced tools out there for non-destructive technique, geophysical location, as well as new advanced technologies like the AI platform that we use, and this is not a trick question, is there a silver bullet technique or technology out there for ensuring that we identify everything under the ground?
The short answer to that is absolutely no. There is not anything, there's not a GPR system, there's not one single system that can find every single underground utility. Like we were talking about in the ASCE 3822, one of the major things that they take a look at is, hey, there's all these different geophysical techniques, non-destructive techniques that should be used and could be used on a project. Now, one of the things that I see in commonplace is that a general contractor may hire Joe off the street that might be able to locate a underground utility with pipe and cable locator. And that's great. But there's about 5 or 6 different geophysical techniques out there. Some of them are more professional grade and more applicable to actual geophysicists that use those systems. But when you combine all of these different techniques in coordination with each other, you're able to actually locate not only just the utilities out on site that are showing up in as-builts, but you're also able to identify unknown utilities. You're able to determine depth or approximate depth to utilities. And now you can start to kind of build up a mental picture of what's going on. Now, the next change to that would be, okay, well, we've located all this infrastructure out in the field. Now, where do we go from there? You know, is it as simple as, you know, putting paint and flags out on the ground like 811 does? Or is there something more that we could be doing to increase our ability to show show where the utilities are and how it affects all of our construction projects and how it can affect even the design?
Thank you, Aaron. We have about a little over 3 minutes left, so I'm going to wrap up the questions with you, Matt. So considering stakeholder collaboration strategies and best practices that perhaps you've seen in the industry, which of those would you think or do you believe are having the greatest impact on improving utility management and coordination, especially in the early phases of infrastructure projects?
So a lot of times contractors get involved like in a bid build environment after the design's finalized and all the utility collaboration and innovation has passed and the plans are fully baked. But you know, having worked in the CMGC environment for about 5 years, it's you get involved early. The contractor gets involved early. A lot of times there's a collaborative environment with the owner, the right-of-way, utilities, environmental, permitting agencies. So as it pertains to the traffic jam of utilities, underground utilities, typically the first step is developing a conflict map with the new improvements. And typically what I've seen is the utility engineers digging up information for months or years on as-built and permits, and it's quite cumbersome. So I'm currently working on about a 250-mile linear utility install project, and we're actually working in the preliminary stages, working with 4M on trying to streamline that utility investigation. Instead of spending, you know, 6 to 18 months investigating utilities, we could do that a lot faster, streamline the process, and deliver a product to the end user a lot faster. So I believe the digital transformation and delivering projects is going to be instrumental in getting complex infrastructure projects delivered. And a real life example on one of the last projects I was working on, there was a 16-inch high pressure gas line, and the initial set of plans that we got had an extreme amount of risk working over this gas line that distributed gas to the whole Central Coast. And we were able to provide, we were involved early enough with the utility companies, the designer, and the owner, and we were able to provide an alternative design that mitigated the risk for the gas company, mitigated the risk for the owner, and it was just a triple win for all involved. So.
Great. So that wraps up our questions. Steve, Aaron, and Matt, I want to thank you for participating. Before we end, we have about 60 seconds left. Any questions for any of our panelists here? No. Okay, it's time for a beer. Ken, I'll turn it back over to you again. Thank you so much.